magnetic field due to a straight current carrying conductor. But before that, it should be known to us magnetic field due to a current element, which is given to you by Biot-Savart law. The magnetic field due to a current element is nothing but B equals to mu naught by 4 pi IDL sin theta by R square, which is Biot-Savart law that is known to us. And we are going to use Biot-Savart law in order to find out the magnetic field due to a current carrying conductor at some point P in the space. For this, say XY is a current carrying conductor. Say I current flows in the conductor and P is any point in the space. Let us drop a perpendicular from P to the wave or to the conductor. This is 90 degree. And P at a distance of A. This is at a distance of A. That's the perpendicular distance of the point. Now, from this point, at some distance L, we have considered a very small part of the wave. And this is your length, suppose dl. This at the point A, we are going to consider a infinitely small part of the conductor. So dl means infinitely small. That's known to us. It's a mathematical tool to represent some infinitely small quantity. L is the length, infinitely small length, so just mathematically you represent dl. Then IDL, I means current, so that's your current element IDL. So current element is known to you. Say it's a conductor, I current flows. Consider a small part, very small part of the conductor. Through that also I current flows. So current into that is length dl. IDL is the current element. So here current element we have considered. So let me give here IDL. Now from here you can say position vector of P. From here in this direction you can say position vector of P is R vector, or simply you can say that P is at a distance of R, and this position vector makes an angle theta with the wave, with the conductor. So this current element definitely will produce some teeny magnetic field or a small magnetic field at the point P, and that value is known to us. Now the magnetic field, let me write here, the magnetic field due to current element IDL at P, and which is given by Biot-Savart law, is dV equals to mu naught by 4 pi IDL sin theta by R square. So you can write here by or according to Biot-Savart law. According to Biot-Savart law. This is known to us. After that, it's a length of finite length. The conductor has a finite length. Now see, you can consider this type of current element, and you can say that this length, the total length, is nothing but sum of all this dl. It means if you sum up all this dl, or if you take the sum of magnetic field, that is total magnetic field is nothing but the entire magnetic field which is contributed due to this current element, these types of current element. That means this current element here you can consider here throughout the conductor. That means this conductor is nothing but sum of all this small length dl. So simply now, if you take the help of integration in this case, then you will get the entire magnetic field or total magnetic field due to this conductor. তো মই কি কৈছো যে আমি প্ৰথমতে গোটেই কণ্ডাক্টৰৰ কাৰণে ডাইৰেক্টলি ম্যাগনেটিক ফিল্ড ওলাব নোৱাৰিম। আমি কণ্ডাক্টৰৰ এটা স্মল বা সৰু লেংথ লৈ ললো আৰু এটা ইনফাইনাইটলি স্মল লেংথৰ মাজেদিও আই কাৰেন্ট ফ্লো হ'ব। এইটো যদি কণ্ডাক্টৰ হয় আই কাৰেন্ট ফ্লো হৈ আছে, তো ইয়াৰ এটা যিকোনো ইনফাইনাইটলি স্মল লেংথ ল'লে তাৰ মাজেদিও আই কাৰেন্টে ফ্লো হৈ আছে। তো আইডিয়েল আমি কারেন্ট এলিমেন্ট হৈ যাব আৰু সেই কারেন্ট এলিমেন্টৰ কাৰণে এটা পার্টিকুলার ডিস্টেন্সত ম্যাগনেটিক ফিল্ড কিমান হয় বায়াস এবাৰ্ট লয় আমাক দিছে। তো এখানে আমি বায়াস এবাৰ্ট লয় এপ্লাই কৰি dB, that is your infinitely small magnetic field, which is given by this. তো এতিয়া ইয়াৰে ইন্টিগ্ৰেশন যদি আমি লৈ লওঁ তেতিয়া হলে আমি এন্টায়াৰ কণ্ডাক্টৰৰ কাৰণে কিমান ম্যাগনেটিক ফিল্ড বা টোটাল কারেন্ট গোটেই কণ্ডাক্টৰত যিমান কারেন্ট ফ্লো হৈ আছে বিকজ অফ দিস এন্টায়াৰ কণ্ডাক্টৰ টোটাল ম্যাগনেটিক ফিল্ড আমি পাই যাম। যি নহওক এতিয়া আমাৰ কাম হ'ল we have to take the go for integration. আমি এই db ইন্টিগ্রেশন কৰি দিলে টোটাল ম্যাগনেটিক ফিল্ড b আহি যাব। তো ইটস এ সিম্পল। নাও সি মেইন কথাটো হৈছে ইন্টিগ্রেশন কৰিব যাওঁতে কিছুমান কথা আমি ইয়াতে চাই ল'ব লাগিব যে ইন্টিগ্রেশন যেতিয়া কৰা হয় তেতিয়া ইন টার্মস অফ ওয়ান ভেৰিয়েবলত থাকিব লাগিব, যেটো ইন্টিগ্ৰেন্ড বুলি কয়। মানে whenever you will go for integration of fx dx, so fx whatever is the function it should be in terms of one variable, independent variable এটা হ'ব লাগিব। সেইখিনি কাম বাকি সব ম্যাথমেটিক্স ইয়াতে। তো সেইটো কৰা হৈছে ইয়াতে চোৱা যে আমি ইয়াতে ডাইৰেক্ট ইন্টিগ্ৰেশন লগাই দিলে ইয়াতে i বাৰু কনস্ট্যান্ট আছে, কিন্তু dl যে আছে dl তোমাৰ কি হৈ আছে ইয়াতে sin theta constant theta মানে because theta vary কৰিব, theta তোমাৰ vary কৰিব। আৰু ইফালে length of conductor এটো যেটো finite length কৈছে যিকোনো lengthৰ conductor হ'ব পাৰে। তো in that sense length তোমাৰ finite length যদিও হয় তাহলে 5 মিটাৰ না 10 মিটাৰ না 20 মিটাৰ, that is not constant. Now see r আরো ভেরিয়েবল হৈ আছে। এই যেটো কারেন্ট এলিমেন্ট যদি ইয়াতে লোৱা তেতিয়া আরো ডিসটেন্স বেশি হৈ যাব, কারেন্ট এলিমেন্ট এটা হলে আরো ডিসটেন্স কম হৈ যাব। তো আমাৰ ভেরিয়েবল r আছে, থিটা আছে, dl আছে, এই গোটেইখিনি আমি চেঞ্জ কৰি ল'ব লাগিব এটা ভেরিয়েবলত। তো সেইটো আমি কি কৰিম এতিয়া চাই লোৱা। তো এইখিনি হোৱাৰ পিছত আমাৰ মেইন কাম হৈছে জাস্ট টু কনভার্ট অল দিস ইন টার্মস অফ ওয়ান ভেরিয়েবল। তো ফার্স্ট আমি কামটো কৰি লওঁ। তাৰ আগতে এটা বস্তু চাই ল'বা যে থিটা this angle is phi, এই অ্যাঙ্গেলটা আমি phi লৈছো। phi এই কাৰণে লৈছো ইয়াৰ পৰা যদি আমি চাও কারেন্ট এলিমেন্টটো তো এট এন অ্যাঙ্গেল phi চাই আছো। এটা আমাৰ হৈছে কি গোটেই তারডালৰ কাৰণে ম্যাগনেটিক ফিল্ড লাগে। তো গোটেই তারডালৰ লেংথ যদি কভার হয় এবাৰ তুমি ইয়াত চোৱা, ইয়াতে যদি চোৱা হয় তেতিয়া phi অ্যাঙ্গেলটো চেঞ্জ হ'ব, phi অ্যাঙ্গেল চেঞ্জ হ'ব, ইয়াৰ পৰা এইখিনি হ'ব phi অ্যাঙ্গেল। আৰু যদি x পয়েন্টক তুমি চোৱা তো এতিয়া তোমাৰ phi অ্যাঙ্গেল ইফালে বেলেগ হৈ যাব, এইখিনি হ'ব phi অ্যাঙ্গেল। সে আমি কৈ দিও এইটো -phi2 -phi1 বুলি কৈ দিয়া আৰু ইফালে কৈ দিয়া phi1। So let me repeat this. This angle is phi, and if I look top of the wave, that is x point, in that case phi value becomes phi1. And from here, if you look to the bottom of the wave, that is y point, then phi becomes sorry, it is phi2, let me write, it is phi2. This is a and this is your phi2. So মই কি কৈ আছো ইয়াৰ পৰা p পৰা এটো is a reference line, perpendicular distance, this is your reference line, and as you are to find out the magnetic field due to the entire straight conductor, whatever current flows here, so for that the entire length you have to cover, and you look to the top of the conductor, then phi becomes phi 2. Phi becomes phi 2 from here. This phi becomes phi 2. And from here, if you look at the y point, then phi becomes your minus phi 1. So in this side, I have taken minus phi 1. So integration, range of integration will be minus phi 1 to phi 2. The range of integration minus phi 1 or phi 2 লৈ গেলৱা তেতিয়ালে গোটেই ব্ল্যাঙ্কটো আমাৰ কভার হৈ আছে এতিয়া আহিযোৱা যে implies integration of dv integration of minus phi 1 to phi 2 mu naught by 4 pi I dl sin theta divided by r square. So in next step you see what are constants here and take out the constant outside of integration. So here a constant ki hoye ase etu baru tumar b hoye jabo total magnetic field and mu naught by 4 pi is constant, current I is constant. So here mu naught I by 4 pi. So constant that we have taken out integration minus phi 1 to phi 2 I dl sin theta by r square. So this much we have. Now our main thing is that we have to transform all this in terms of one variable. So first of all, so I is constant, I have taken out one by one. Say sin theta. We are interested to convert everything in terms of phi. Karon so phi jodi change hoy egotei khini cover hoy. Phi change hole theta change hobo. If phi change hole tumar aro change hobo. So phi egotei khini kaam kori ase. Gotike egotei khini in terms of one variable lobo lage mane gotei khini in terms of phi loi loa. So prothomote theta saba in right triangle OAP, say this point is A, OAP. In this right triangle, this angle is phi, A angle to tomorrow phi, this angle theta. So phi plus theta is equal to what? This is the 90, so phi plus theta must be 90 degree. So from here, theta will be equal to 90 degree minus phi. Then sin theta will be what? Sin theta definitely sin of 90 minus phi, that will be your cos phi. So A to be jabo tomar cos of phi. So ekhini loke clear amar. So sin theta amar uddeshyo asil gotekhini in terms of phi loa, sin theta ami in terms of cos phi likhi lolo. Mane in terms of phi ta ahi gol. Next aha say now r, this variable you have to convert. So for this, again this is your r, this distance is your r, APR. Again you consider the same right triangle OAP. So in right triangle OAP, in this right triangle, what you will get, you see, let us take your, this is your phi and sin of phi, or you can say cos of phi equal to, if I take cos phi from this right triangle OAP, cos phi value ki hobo base by hypotenuse. So base ki hoye ase a by hypotenuse kiman hoye ase tomar r. So gotike base hoye jabo a by hypotenuse r. Yar pora tumi r or value ulai thoa, r will be a by cos phi, that is nothing but a sec of phi, So r or value in terms of phi likhi lola. Next a to constant or kaam koribo iate, karon jitu point loisa etu fix, tare pura perpendicular distance to change nohoy, because a represents the perpendicular distance. R change hobo because current element to tumi yer lobo pora etu change hobo. নেক্সট আহা আমাৰ এতিয়া ডিএল চেঞ্জ কৰাব লাগে ডিএল তো এগেইন ইন right triangle OAP. To make you understand, I am writing again and again in right triangle OAP. In your exam, once you can write in right triangle OAP and all these values you can calculate together. So in right triangle OAP, I will take 10 phi. 10 phi. This is the most important step. How to get the value of DL? DL value to keneke baba. তোমালোকে 10 phi লগাব লাগিব 10 phi 10 theta কি আছিল in right triangle 10 phi will be your perpendicular by base so it is 10 phi this angle is phi in this triangle 10 phi will be perpendicular by base that is L by A that will be L by A this is nothing but L equal to A tan of phi A tan of phi so let me write here. So if you get L equals to A tan phi, then you have to differentiate this to get the value of DL. So differentiate korile DL paba. So DL tumalokor ki ahibo A sec square phi. A sec square phi d phi. Differentiating this, DL is equal to A sec square phi d phi. So this you have now you see DL in terms of phi, sin theta in terms of phi, and R in terms of phi. তেতিয়া কাম কিটা গোটেইখিনি ভ্যালু ইয়াত বহাব লাগে তো আমি এটা এটাকে ভ্যালুখিনি পুট কৰি দিম after that let us put all these values now you see this b equal to so it is your mu naught I by 4 pi integration minus phi 1 to phi 2 then 1 by 1 at first you write DL is your A sec square phi d phi so let us write A sec square phi d phi তো তোমালোকে DL এর ভ্যালু বহাই দিলা A sec square phi d phi next sin theta is what cos phi into cos of phi divided by R is your A sec phi so R square will be A square sec square phi A square sec square phi so now since some terms will be cancelled out implies b equal to mu naught I over 4 pi and a cancelled out sec square phi cancelled out so only a left take out a is constant here independent of phi actually minus phi 1 to phi 2 and what is left here only cos phi d phi this part is left. Now it's a simple integration of cos phi is what integration of cos phi d sin phi equal to mu naught I by 4 pi a sin of phi so limits minus phi 1 to phi 2 minus phi 1 to phi 2 then put the limit mu naught I by 4 pi a into then sin of phi 2 minus sin of minus phi 1 and sin of minus theta is your minus sin theta that's why sin of minus phi 1 will be minus sin phi 1 so that will be plus sin phi 1 so we have derived the expression for magnetic field due to your current in a straight conductor. So straight conductor যেটা current flow হয় তারে পরে a distance magnetic field কিমান থাকিব আমি ডিরাইভ কৰিলো that is b is equals to mu naught I by 4 pi let me write here, B equal to μ₀I by 4 pi into sin phi 1 plus sin phi 2. So this is the expression for magnetic field at a distance, say, from a state conductor due to current I which flows in the state conductor. So B equals to μ₀I by 4 pi sin phi 1 plus sin of phi 2. And one most important point, whenever you will use this formula for numericals, now just remember that you don't phi 1, phi 2, whatever values are given, you don't take the negative in that case, because already the formula we have deducted taking phi 2 as phi 1 as negative. So in case of numerical problems, we are not going to put negative sign in the angles. Whatever way angles are given, from in case of numerical problems, phi 1, phi 2 we will consider as positive values, and we will just put the values phi 1 and phi 2. So we will solve numericals. In that case, I will clarify this. So after this, some special cases are there, so let me explain this also. So if the conductor is infinitely long, যদি তোমাৰ কণ্ডাক্টৰটো ইনফাইনাইটলি লং হয়, তো তুমি ইয়াৰ পৰা চাব পাৰিবা যে এইটো কণ্ডাক্টৰ আছিলে, তো এইখিনিত আমাৰ পইণ্টটো আছিলে P, আৰু this is the perpendicular distance. So this angle was your, from here this angle we consider as phi 2, আৰু এই angle তোমালোকে লৈছিলা phi 1. This angle is phi 1. If it is infinitely long, then you see phi 2 increases, and it will be almost 90 degree, and phi 1 also almost 90 degree if in case of infinitely long conductor. So for infinitely long conductor, these are the special cases actually. Phi 1 equal to phi 2, both are 90 degree. So in that case, sin 90, sin 90, 1 plus 1, 2. So then magnetic field at the same point P, that will be μ₀I by 4 pi into, so here it is A, sorry, it was missed, 4 pi A. 4 pi A was there. μ₀I by 4 pi A into 2. So, or you can say 2I. So better to write like this way, B equal to μ₀ by 4 pi into 2I by A. And you don't cancel out this with this, because μ₀ by 4 pi is 10 to the power negative 7. If you keep as it is, then directly you can write 10 to the power negative 7. And that means you can say that is B equal to 10 to the power negative 7 times twice I by A. So this is also you can keep. It's up to you. If you want, you can cancel out this. Second case is there, a special case. So this is one fact. Another fact is that this is the conductor, same conductor, and if the P point lies at the end of one, they say it is your P point, and this is your infinitely long in this end. So what I says, this is a conductor, at this end, near this end P lies. P lies at near the one end of the conductor, and other end is infinitely long. So in that case, what happens? Phi 1 is 90 degree and phi 2 is 0. Or you can say P, this is the phi 1. In that case, what happens? In this case, phi 1 equals to 0, and simply you can say phi 2 equal to 90 degree. So if you put here 0, sin 91, in that case, magnetic field B will be your μ₀I by 4 pi A. μ₀I by 4 pi A. This is the special case. If the point P, at the point where you are calculating the magnetic field, that point lies at one end of the or near the one end of the conductor, and rest of the conductor infinitely long. In that case, one angle will be 0 degree and another angle will be your 90 degree. So in that case, the value of magnetic field will be this. So this is the complete deductions of magnetic field due to a straight current carrying conductor. In next class, we will take or we will try to deduce the magnetic field when current flows through a coil or circular loop. So at the center, what is the magnetic field? We will deduce it. Thank you.